Hi everyone, my name is Diana Ulibarri and my partner is Anna Andrade, and our chapter presentation is regarding number sense and mastering the basic facts, chapters 10 and 11. Before we jump into our presentation, I wanted to give a brief intro of both chapters and what exactly you guys will be looking at as a class. For chapter 10, number sense is developing fluency of the basic facts of numbers. So students will be learning different strategies and methods in order to learn how to properly use addition, subtraction, even multiplication or division, whatever math that they are going to be solving. They will have certain strategies, and it is important before they get those strategies that they understand what is of the numbers. So for example, what comes before certain numbers, what comes after certain numbers, what two numbers can make another number. For example, 5 plus 5 will always equal 10. Grouping methods, they're going to learn all about that in this chapter. They're also going to learn how to demonstrate different strategies. As an educator, we got to be aware that many students have different learning styles. One method that may have worked for us as students will not necessarily work for them as students. Going through school for so many years, I can honestly say that I remember certain strategies that I was taught. However, as I went through different grade levels every year, I got taught a different strategy that may have seemed to work a little better than the one I was used to before. So same thing with our students. We got to be aware that they have different strategies they are comfortable with. And in this chapter, they're going to learn, and we're going to be able as educators to see why they possibly are choosing these types of methods compared to different ones. Are they a little more advanced than some students in this area? What kind of thinking are they using? This chapter kind of gives us an idea, which is why I thought it was so interesting to kind of see why students will choose certain ways to do their math problems. Some ways that I was not even aware of that they were using. So this chapter focuses on that. They will also describe number sense, so they will be able to understand why it's important and why they need it to be successful in this subject. Math is a very hard subject for a lot of people. I personally struggled with math a lot during my school years. I did it and I finished, but however, it did take me a while to understand the subjects. I was one of those students that really had to work at it all the time. So some students are different, and now they're going to understand why it's so important and why some students struggle with this subject in general. For the next chapter, chapter 11, which my partner Anna did, she focused on mastering basic facts. And for basic facts, they're going to understand what exactly do they need to master? What exactly are educators looking for? And what are we supposed to be teaching them so they are successful when they come up to different strategies, whether it's addition or division or multiplication? They have strategies that they have to be aware of, and certain facts and basic facts they have to have mastered before they can apply those theories. They're going to learn the importance of place value and concept, the importance of pre-place value concepts, and they're also going to learn about grouping. For example, multiplication is a lot of grouping methods and a lot of grouping strategies used in that category. One times whatever number, one times one is always going to be one. One times three is always going to be three. They're going to learn different grouping methods for that chapter. So as you guys have a brief introduction, we are going to jump into chapter 10, which is number sense. So first, what is number sense? For students that don't know what number sense is, it's basically the understanding from a very young age of number sense is developing fluency of addition and subtraction. Concepts begin in kindergarten and will continue through grade 2. So at a very young age for number sense, we are learning number sense before we even know exactly what it is. So for example, in kindergarten, students are usually learning the basics. 0 plus 1 is 1. 0 plus 2 is 2. They're learning the differences of numbers. And for the most part, they're memorizing which number is in order. So from 0, 1, 2, 3, students are memorizing all of that. And in this chapter, we're going to talk about different strategies that help students with number sense from a very young age, with memory and memorization being one of them. But we'll get into that a little bit later. Something interesting about number sense is that researchers can actually indicate that number sense can predict school success, other measures of cognition like verbal, spatial, and memory skills. When I was looking up this chapter, that was very interesting. Number sense can play a big role in our success in the classroom. It actually helps our brains develop certain methods, certain styles of how we're going to learn. For example, some kids are very good at memorizing. Some other students really can't memorize that well. They're more hands-on. That's how they learn things. Some students are not able to do hands-on things and find them as successful, and they're more just look and visualize and memorize it. Some students are not comfortable verbally, and some are. There's so many different ways students can come about number sense, but from a very young age, when we are shown number sense, which usually starts in kindergarten, it has a huge impact on our education as we grow as a student. And for the Common Core standards, students will help flexibly, accurately, efficiently, and appropriately learn how to solve a problem. In math, we are always solving problems. There's always different outcomes for problems, especially word problems. They're always different, and especially in the higher maths, any answer can be a right answer, which we won't focus on, but it helps a lot with problem solving, maybe not just in mathematics, but in other subjects as well. And lastly, number sense is important because students will have a hard time moving forward in mathematics, but in any subject, number sense is fundamental of learning, and some students will master it sooner than others. So a quick overview of the main concepts of number sense. These are some ways and popular ways that educators will help students understand number sense. Memorization, which I explained, some students are good at memorizing 0, 1, 2, 3, 4, 5, the whole number set. Kids are good at memorizing that. Explicit strategy, which is a different way for students to understand math. So for example, some students cannot understand or memorize a certain concept as well as others. Explicit strategy kind of shows them a different way. For example, some students will say 10 plus 10 is 20, and they can easily say it because they memorized it. Some students who are not strong in mathematics, 10 plus 10, they would have to use their fingers to count. Explicit strategy is a different way for an approach for students who maybe are not as strong at memorizing different stuff. Guided invention is a strategy that I like to say is more of a do it as you feel strategy. Believe it or not, some students are like this. Some students are not comfortable with certain strategies. As I mentioned before, they're not comfortable with it and they don't want to use it, or they don't understand it and they kind of give up. They feel defeated. Guided interventions is having an educator stand in front of a classroom and not give a specific method or strategy for their students to use. Students can choose a strategy that works for them. For example, if they were to do an addition lesson and some kids were able to memorize the addition and quickly come up with the answer than others, while there's other ones who prefer maybe to hands-on learners have little blocks in front of them. What's 5 plus 5? And they would add 5 blocks and they would come up with the solution, which would be 10. This way, the educator is allowing the students to feel comfortable and maybe not feel so pressured to follow one specific method. They are kind of able to just go and do as they please. As myself, I want to say I kind of was that type of student. I had certain strategies that I felt comfortable with, but at the end, if the teacher was using a specific strategy that I didn't really agree with or I didn't feel comfortable with, I would go back to one that I knew I was comfortable with. So guided interventions is pretty much allowing students to work on the subject as they're most comfortable with. So for memorization, for our first one, some students are very good at memorizing stuff, and others, they just can't remember anything. They can barely remember what they had for dinner the night before. This approach moves from presenting concepts of addition and multiplication straight to memorization of facts, not devoting time to developing strategies. Some students are able just to look at material and get it. They understand right away. Others takes a little more time. They can't memorize it. They always have to look back at their notes. They always have to sit there and kind of think about it. Nothing wrong with that, but memorization is a very successful, quick strategy for students who maybe are a little more advanced and a little more comfortable with the subject. Down here is the citation from our book for the semester, if some of you guys were wondering. Explicit strategy, as I said before, is more of a do it as you please style. For decades, explicit strategy instruction has been used in many classrooms. Students learn a strategy, for example, combinations, whatever it is. Some students struggle with memorization. So explicit strategy kind of takes that pressure off the students, saying, hey, you have to do it this way. They can kind of relax and say, well, I didn't like this strategy. I'm going to go with the one that I like to do, how I do it, whether it takes me longer or it's shorter. Most cases, it takes a student a little bit longer and they might feel a little embarrassed because they're not finishing with their classmates. However, they choose this strategy without knowing what it is because they're comfortable and they can feel confident that they're understanding the material. So, for example, a student who say has memorization strategy pretty well. They don't need hands-on or any type of visual to understand the problem. For an explicit strategy person, they would say 5 plus 5 and they would think about it and it would equal 10. For them to get this solution or this answer, they would most likely need something in front of them, whether it's blocks, a piece of paper, whatever it may be, for them to visually or hands-on work out the problem. That would be their way of doing it. As for someone with memorization, they would say, oh, 5 and 5, they're equal to each other. It's going to equal 10, which would be a solid number. So it just depends on the style of the student. For guided inventions, a guided invention, again, is a strategy where an educator may not explain a specific strategy to a student, however, allow students to solve the problem their own way. So, and again, as I go over it again, I myself as a student, I would want to say I did this a lot. As I said, I struggled in math a lot and I constantly had different strategies I was trying to use. But even when I got to college and I had to take math, I found myself using strategies that I haven't used in a long time just because I knew that I was comfortable with them. And although my professors never said anything in college, they still understood the way I was doing the problem, even though it was different than when it was being shown in class. But that's just something that worked for me as a student. I also knew students who could just look at the board and get it and use that strategy the professor or the teacher is using. But for guided inventions, for example, a student who has basic math skills can simply add 5 plus 6 is 11. So their thought process for a student who, say, is very good at memorization would be 5 plus 5 is 10. So add 6, who is 1 more than 5, it would equal 11. So for somebody who's very good at memorization, they can instantly go through that whole process within a couple seconds and come up with a solution. Somebody who is kind of more towards the guided inventions, for example, like myself, they would see a problem like 5 plus 5. I would think of it as, okay, I have 5 blocks and I need to add 5 more. So I would get 5 more blocks, whether I had to draw them or had them in my hands physically. I would know they would make 10. So as I mentioned before, some students learn better this way, although they may feel like they're not smart enough or they're not thinking fast enough as someone who could just sit there and do all of this math in their head. This is another way for students to kind of ease that pressure off, as I said beforehand. So understanding the basics. So all of the strategies that I just went through, we need as educators need to make sure, are they meeting the basic fact fluency? Are our students really understanding why they're choosing these strategies or which type of learner they are? For the aspects of fluency, we have appropriate strategy selection, flexibility, as we mentioned in the first slide, efficiency, and accuracy.